So continuing the same trick of ratio method to find out the charges for a circuit with capacitance in series and parallels, let us do this question and understand what is asked and what can be done. Obtain the equivalent capacitance of the network in the figure. So they have already told us to obtain the equivalent capacitance for 300 volt supply, determine the charge and voltage across each capacitor. So what they have given is V is equal to 300 volts. Then they have already mentioned the capacitance on each of them, and you have to find out the total equivalent charge first. Then charge on each capacitor, that is the next part of the question. Voltage on each capacitor, that is another part of the question. This is the query. Now, using our method, let us find out equivalent capacitance for which. First, let us identify which are the capacitors in parallel and in series. Fine. So again, as usual, let us start from here. Okay. Let us start from here, and there is a junction here which goes this way or this way. As I said, a T junction is formed from the source after the source has started. Okay. So here we can say Q1 is the charge. Here we can say Q2 is the charge. And Q1, Q2 join together and we get Q here joined together. So meaning Q is distributed into Q1 and Q2. Agreed? So we have to find out Q, then we will distribute it into Q1 and Q2 by ratio method of capacitance. Fine? Okay. Then one more thing, they have asked us to find out the potentials also. So let us, voltage also across each capacitor. So let us name the voltage here as V1. For C2, let it be as V2. This is C1. This is C2. So V1, C1, V2, C2, V3 for C3, and V4 for C4. Okay. And remembering that for a series combination, charge is same, and for parallel combination, potential is same. Fine. So for V2 and V3, Q1 is the charge, and for this line and this line, potential remains the same. So we can write V1 should be equal to V2 plus V3 together.